Hello students, I am Tanmay. I welcome you all in my channel Chemistry, the Mystery of Molecule. It's a continuation lecture of Grignard reagent preparation. Okay. In first two videos I have explained about the basic concept on Grignard reagent preparation mechanism. In second video I have described about the aryl magnesium halide or acetylene based Grignard reagent preparation. So right now we will discuss some problems and difficulties regarding di-Grignard reagent preparation. Okay, we have previously discussed about mono, this is a di-Grignard. So let's discuss this problem. So today we are going to discuss about this 1, 2, 3, 4, 5, 6 and 7 problems. Okay, so let's start. So you can see the first example. This first example is about alene preparation. Alene is a unique type of molecule having carbon is attached to two double bonds. Okay, and this thing I'll explain in later. It's as a unique geometry. What do I mean? See, this 2-methyl is in front, this in the plane, and these are front and back, and this pi bond and this pi bond, they are 90 degree perpendicular to each other, and sorry, not centrifugal, and this carbon is sp hybridized. So this is the uniqueness of this alene. So how this reaction is happening? This reaction is happening by, first you can consider that. So let's draw here. No, it will be difficult. So let's draw it here. So first let's this think that one Grignard reagent will definitely be prepared. Okay, so 2 electron Grignard reagent will be prepared. I am not going to explain this mechanism because I have explained in the previous video. Please go through that, it will be helpful. So see, so first there is one CBr bond, so one Grignard reagent will definitely be prepared. Fine. Now as we know that Grignard has a sufficient negative charge, so we can consider this means bond polarity around 34%. So we can consider it this way. So what happens that this negative charge will push here, will go there, and this bond will break and come here, and it will leave. Fine. So actually the bond between this dimethyl is breaking, and in between this carbon is coming. Okay, so that's how this alene is formed, and this 2-bromo leave, it results in MgBr2 plus this alene derivative. Okay, it's a strategy or method to prepare such alene moiety. Okay, fine. Now let's discuss about the second problem. So let's come to the that was, you can consider previous example was 1,1 dibromide. 1,1. Now it is 1,2 dibromide. 1,2Br. Fine. So if we provide magnesium, what is expected that it will provide this magnesium bromide. Fine. There is one bromide, and this is actually negative charge, so this bond can push here and this Br can leave. So consequently what will be produced? It will produce ethylene, CH2 double bond CH2. See, there are previously 2 carbon, 1 and 2, so that's why 2 carbon double bond is formed plus MgBr2. Fine. Similar thing is applicable for this magnesium also. So in first stage what it will prepare? It will prepare this one side Grignard MgBr, and this is Br. So this attack here to leave to produce this cyclopropane derivative. Cyclopropane. Now question, how this 3-member ring is forming? We know that 3-member ring is relatively strain difficult, but because only one thing, proper conformational orientation. Due to this proper conformational orientation, this 3-member ring is formed. So what we have learned from 1,1 to 1,2 to 1,3, if we try to prepare Grignard reagent, so Grignard reagent is produced, but that is not stable because that reacts further with the another to prepare some other, for example 2-member ethylene, 3 member cyclopropane derivative and 1 member for alene. Okay, means 1 more. So now it is, you can see this is actually 1 4 1 2 3 4 or higher, means 1 5 1 6. What happens? So as like other first stage, it is expected that this reagent will be produced. So fine, and see right now if it forms, it's a 4 member ring formation, so not that much stable. That's why the second Grignard reagent formation also takes place. MgBr, this is MgBr. This is the second Grignard reagent preparation, but keep it in mind this reaction is not that much easy because it's not that much stable, and that's why low yield, around 30% yield is observed, but these indicate that it happens. Okay, so that is the thing. Similar case of similar phenomena is observed relatively higher Grignard reagent also. So now let's consider the cyclic. We have described here the acyclic 1,4. Let's discuss about what happened if we use cyclic di-halide. Fine. So here you can see the product is produced. There is a double bond. Fine. When problem related to cyclohexane given in saturated, it is better to draw the chair force. Okay, and we know the bromo is relatively bigger atom, so it will prefer the actual side. Here it should be stereochemistry should have mentioned, but they didn't mention. So let's think in this way. This is diaxial, and since this target final product is mentioned, so let's consider in this way, because you will understand that you can explain the phenomena properly. So in terms of magnesium dry ether, okay, one thing, always dry ether is necessary, because if moisture is there, that will react with magnesium, not the Grignard reagent, not the CBr bond, because moisture is more reactive compared to water, is more reactive for magnesium compared to this bond. And another thing, for example, if it is produced also, there is a carbon ion, so it will instantly react with moisture to abstract a proton and form this means CH, and Grignard reagent will be destroyed. So what happened? Let's consider one part is converted into the Grignard reagent, MgBr. Now what it will do, this carbon ion will push here and it will push here, it will leave to finally produce, see, this bond is broken, so just draw as it is. This is double bond and this is this, so this bond is broken, this bond is broken, this bond. So I am not writing, just this is H, this is H. So then after you write, because this is 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6. So exactly same. Fine. So question how and why. So let's draw it again. So as you can see, Grignard means it's a carbon ion. You may consider like that because it's a sufficiently polar. This and this carbon ion is in this sp3 orbital. Okay, this is the negative charge. So what it can do, this carbon ion, this is the sigma bond, its sigma star looks like this. So this overlaps with this, and if this electron is donated to the sigma star, if we draw this plus minus sign, sigma star, then this sigma, this bond is broken. Fine. So if this broken, consequently what is expected to produce? Stepwise explanation. So this bond is broken. Right now the lone pair is in this orbital. So the electron pair means carbon ion is here. So it is here. And similarly Br is here, hydrogen. So this bond has sigma star also. So plus minus. So this form overlaps with this, consequently this bond broken. So ultimately it produces this. So this is the stepwise explanation for the preparation of this double bond derivative. Fine. So okay, we have learned this. Now discuss about the next example. See, it is 1 4, it is 1 2. You can 1 3, 1 2 3, 1 2 3 4. So if it is 1 3, what is expected? For that you have to draw the Packard structure also. This is the Packard structure. This is, and similar, since they have mentioned this, similar. Okay, so means exactly not this, you can draw it in this way also. Means whatever the, okay, it is more logical. So this is, so first it will be prepared, produce Grignard, means mgx. After that this will attack here and it will leave. The same explanation like 3-member reinformation. So what it will produce? The bond between these two will be produced. This is happens because of proper conformational orientation. This 3-member is formed, although energetically they are not that much stable. Fine. So now we have discussed this type of reaction, that ring system, some changes, means unexpected reaction. But here you can see expected Grignard reagent is produced. Question 1. First of all, you have to see this is a non-boring derivative. It's a locked system. This is a locked system. Why? Because of presence of this CH2. Fine, it is a locked. Now, these bonds are not anti to each other or syn to each other. That's why, for example, let's consider one Grignard is formed. Here, Pr, hydrogen. So these are not properly oriented because of this locked system. That's why the corresponding mgx, mgbr cannot react with this, and if it cannot react with this, it will again prepare another Grignard. So the reason, because of locked system and no syn or anti-orientation with the CBr, elimination cannot proceed. Elimination does not occur. Fine. So this is the reason for this. So I guess you have learned some unique examples regarding the preparation of Grignard, which sometimes prepare produces Grignard, sometimes not. So this may be helpful for you, I believe. So thanks for listening my video. If you like my teaching, please subscribe my channel Chemistry and Mystery of Molecules and share this video among your friends so that many people will be benefited from my effort. And finally, please press the bell icon to get the notification of every single video I upload. So stay happy, stay cool, God bless you.